Hello and welcome back to Deeksha Karnataka YouTube channel. This is the first class of KCET 2026 preparation, and if you are someone who is watching our video, our channel for the first time, don't forget to subscribe to our channel. Now, if you are someone who skipped your PU1 completely and just able to manage to pass your PU1 exam, then this video is going to be for specifically for you. And no matter what exam you are preparing for KCET, maybe NEET, maybe JEE, if you have skipped your PU1 completely, then this is the bridge between your PU1 and PU2. What are all the necessary things that you must know to understand physics in PU2? If you don't know these concepts, then definitely you will struggle in your PU2. Now, I am not going to teach anything related to physics specifically today's class. We are basically going to discuss about basic mathematics. Basic mathematics was done some partly in your PU1 mathematics class. Some concepts are taught in your physics class as well, and during that time you felt bored and you skipped those classes, or you have completely forgotten those classes. So now here I am to just refresh your memories about those basic mathematics. Okay, and basic mathematics is very much necessary for whatever exam, whatever preparation you are doing. It can be PU, it can be any competitive exam. For all students, all the people who are out there for PU2 preparation, this is the must watch video. Now, today I am going to discuss about trigonometry and algebra. So basically, as you can see here, it is mentioned part 1. That means it will be a two-part video. So in the first part, I am going to discuss about trigonometry and algebra. So let us look into the detailed class structure. What are all the things that we are going to discuss in this two-part video? In trigonometry, we are going to discuss Pythagoras theorem, ratio of angles, degree to radians, and some formula sheets. And don't think that all of the things you know. There are many things. I can guarantee that you will learn something that you are not aware of, or you may have thought that is just a mathematical concept. How can we apply those in physics? That is also very, very important. Next is algebra, quadratic equation, binomial expansion, common formulas. So these two things we are going to discuss in today's lecture. And in the part 2 we will discuss calculus. Okay, now calculus partly you have learned some part in your PU1 classes. You will learn in detail in PU2 as well. Most of the PU2 is based on calculus, yes, but before starting you have to know fundamentals of calculus. I am not going to teach you how to do complicated calculus problems, but obviously the most necessary parts in calculus: function, differentiation and integration. These are the three main pillars of calculus. Then we will have graphs and geometry. Some portions you have studied in your lower grades, 9th, 10th, 7th, 8th even. So we will be discussing about straight line, circle and ellipse. We will also discuss parabola and hyperbola. We will discuss about graphs. We will discuss about some of the geometry formulas as well. So as you can see, none of our bridge course is basically physics. It is basically maths, because physics and maths are the best friends. They go hand in hand, and if you missed any one of the concepts, if you have any doubts that how sir was solving that kind of question, how sir converted into integration and solved it, so every doubts that you might had in your previous classes, those to understand those you have to have this knowledge first. Okay, so this is the basic knowledge. This is the must have knowledge that you need before you start your PU2 preparation. I know many of you have already started it, so even if you are doing it and in the class you may have lacked some basic knowledges, teachers generally do not explain in detail for these concepts, because they assume that you have already done it in your PU1 classes. So that's why teacher just skip it and you don't understand, and backlog starts to cripple you, and at the end of the exam you said physics is hard, I will not go for physics in full-fledged because of lack of this knowledge. So that's why I decided to discuss these concepts in your bridge course today. Now from here on we will start with the first topic of the day, that is trigonometry. So first obviously the Pythagoras theorem. So Pythagoras theorem is what? If we have a right angle triangle, remember that one of the angles must be right angle, that is 90 degrees. So here we have this angle as right angle triangle, 90 degrees. Suppose this side is A, this side is B and this is, we generally call it H. Okay, so these are the two sides of the triangle, and this is this has a special name called hypotenuse. Okay, hypotenuse is the angle opposite to that of the 90 degree, the angle the side opposite to that of the angle 90 degree. Okay, this is called hypotenuse, and the relation is very easy. H square equals to square sorry, not square root, H square equals to A square plus B square. Very easy, right? But sometimes student forget to apply this condition. This is very helpful when you are adding two vectors, okay, two perpendicular vectors, which is very common in across all the exams. Okay, so when you are doing maybe two electric fields, maybe two magnetic fields, maybe just simply two vectors A and B, when you are adding them, if they are in at right angle, you always have to look for Pythagoras theorem. Now remember that no matter whatever equations you are solving, Pythagoras theorem, basic mathematics is always valid. Okay, basic mathematics is always valid, no matter you are solving physics, no matter you are solving chemistry. 2 plus 2 is 4, right? So it is across all the subjects. Similarly, there are some concepts which is valid across the subject. So this is also something which you have to remember. So H square is equal to A square plus B square. Sometimes we directly write H equals to square root of A square plus B square. Now generally the values of A and B are given such that you can do the square root easily. That's how the values are given to you, right? Now let's move on to the ratio of angles. So now before starting, so we said this side is A, this side is B, and this side is H, right? That's how we named it. Now here we will slightly change the names. Here we will slightly change the names based on the angle that we are considering, right? Suppose we are considering this angle, and we are saying this angle is theta. Okay, if we are considering this angle, you have to consider one angle, either this angle or the other angle. Okay, and even if you are considering this angle, you can find the values for the other angle as well. For that there is a trick. We will teach that at the end of this session of trigonometry session. We will share that as well with you. So first let us consider this angle is theta. Okay, if this angle is theta, the side which is adjacent to this angle theta, adjacent means which is just next to it, other than hypotenuse. Hypotenuse will always be there. Other than hypotenuse, the side which is adjacent to the angle, we call that side as base, B. Okay, so we call that side as base, B. So what is the difference, sir? You said A and B. The only difference is that this side is B, and the side which is opposite to that angle, we call that as perpendicular, and we denote it with P, not A but P. Okay, and Pythagoras theorem is valid here as well. H is equal to square root of P square plus B square. Okay, so just we are changing the name for this side, nothing else. It will be helpful for you to remember what are all the ratio of the angles. For example, sin theta, cos theta, tan theta, okay, sec theta, cot theta, cosec theta, they are all called ratio of the angles, right? Now many students often struggle with these values because some of them have not practiced it when they are supposed to do it in class 10th or class 9th. So they skipped that classes because of pandemic, because of the deleted syllabus, because of many other reasons. They thought, okay, I will score well without studying that chapter. So they have skipped that chapter, and now when it is very essential for you to apply that, you struggle. So for that I have a shortcut. Okay, so let's see what is the shortcut. So this is the shortcut that you have to remember. Some people have curly brown hair turned permanently black. Now this is the one that I have learned when I was a student, and this is very helpful for me to remember. This is called mnemonics. Right, you have learned a lot of mnemonics. Maybe there are some mnemonics in your language. Some of you are watching me are from Kannada medium, so they may have learned something which is in Kannada. So that is very fine, that is very good and okay with me, as long as you remember how to find the angles, right? So some people have, some means sine theta, some means sine theta. So sine theta equals to people have, so P by H. So sine theta, sine of this angle is given by, this is a ratio of angle, this is called ratio of angles, okay? So sine theta is given by P by H, okay? This is how they are defined. Curly brown hair, so I hope you have already guessed it. Curly means cos, so cos theta. Brown hair, brown means B by H, B by H, base by height. Okay, so many students confused. Based on the angle, you have to decide which is base, which is perpendicular, and once you have determined that, you have to apply this to find the angle. Then the last one is tan theta. Tan, turned means obviously tan theta. Permanently black, P by B. So this is how you can remember the ratio of the angles. This is how you can remember the ratio of the angles. So while this communicating with the students, especially who are in the PU1 and some students from PU2 also, they often lack this knowledge and they often just write it. They try to memorize this: sine is P by H, sine is P by H, cos is B by H, cos is B by H, and they lost it somewhere. But if you remember just this one small kind of rhyme, not exactly rhyme but a sentence: some people have curly brown hair turned permanently black. So this is basically talking about me. I have curly brown hair, not curly brown hair, I have curly black hair. Anyway, turned permanently black. Okay, so you can say that. So this is how you can remember this sine cos ratio. Right, now let's move on. Now ratio of the angles, you have to remember the values of the sum of the common angles. That is also very, very, very important. Not only important, it's very, very, very important. Okay, so how can you remember all the 0 till 90? Okay, some of you have already used the table, some of you have a picture of this table on your desk. So that is very, very good if you have the picture of this table on your desk. This is not only helpful for physics, it is also helpful for mathematics as well. Now I am going to teach you a small trick. Even if you forgot it, you can remember it in no time. So first we will start with obviously the first angle, which is sine, and in this angle 0, 30, 45, 60 and 90, and sometimes we say this is pi by 6. We will use that how to do that, but this is also very, very important: pi by 4, pi by 3 and pi by 2. So these are the angles in the corresponding radian measurement. We will see that how to convert an angle into radian as well, so don't worry about it. But you have to remember that these are nothing but these angles. Okay, in physics particularly the pi by 2, pi by 3, pi by 4, they are very common rather than directly giving you the angles. Okay, but if you know that, okay, these are nothing but the corresponding angles, you can solve it. Now how to remember the values? So first we will start sine and the first angle 0. So 0 means obviously we will start with 0. Okay, next for that we will put 1, then we will put 2, they will put 3, and last we will put 4. Right, 1, 2, 3, 4, 0, 1, 2, 3, 4, real numbers. Right, so we have written the numbers. What is the last number? Last number is 4. So what we will be doing? We will divide everything with this number. Okay, we will divide everything with this last number. And then we will take square root of everything. We will take square root of everything. Okay. Right. Now 0 by whatever it is always 0, and square root of 0 is also 0. So it will be 0. Now 1 by 4 square root is what? 1 by 4 square root of 1 is 1, square root of 4 is 2, so it will be half. So 2 by 4 means you can cancel one of them, so you get 1 by 2 square root, 1 by 2 square root will be 1 by root 2, right? Root 3 by 4, root 3 you cannot take any root, so root 3 by 2. Okay, and 4 by 4 is 1, so 1 square root is 1. Okay, so these are all the values for sin theta. Okay, now how to do that for cos theta? Cos theta you have to start with this number first, 1, then this number root 3 by 2, then this number 1 by root 2, then this number, that is half, and lastly this number 0. Okay, so basically the order is reversed, and while doing that 45 degrees coming in the middle for both cases, so that's why 45 degree for both of the sine and cos have the same value. Okay, so sine 45 and cos 45 are same, right? So it is 1 by root 2. Now what about tan? Tan is easy, sine by cos. Tan is sine by cos. So 0 by 1, 0. Half by root 3 by 2, so it will be 1 by root 3, 1 by root 2 by 1 by root 2, that is 1, root 3 by 2 divided by half, only root 3, right? Half will go up and cancel, and lastly 1 by 0. 1 by 0 means obviously it is going towards infinity, but sometimes we do not say it is infinity, we say this is undefined. Slightly sophisticated wordings, nothing else. So but just remember, sine 90 degree is basically 1 by 0, so it is basically infinite value. It generally does not come this value, but if you see somewhere 1 by tan 90 or 1 by tan pi by 2, that means this value is 0. This might come in some cases, some particular cases, and you have to remember that 1 by tan 90 is 0. Okay, because it is 1 by infinity, 1 by infinity is 0. So this is the only thing that you have to remember. Other than that, there is nothing need to remember. So this is how you can remember the entire table for sine and cos. And obviously cosec is 1 by sine, sec is 1 by cos, tan cot is 1 by tan. So and they generally do not come too much in physics, except very 1 or 2 particular cases. Mostly sine, cos and tan are sufficient to understand all or solve questions in physics. Sec and cosec you can take the reciprocal and solve it. Okay, so that's why we are not discussing those angles in our lecture today. Now in physics there are the angles does not end over there only. There are two special angles, 37 and 53 degrees. Those are very, very important, and I have not seen too many questions in KCET based on these two angles. But if you are someone who your primary exam is NEET or JEE, KCET is your backup, then you have to remember these two angles as well. In NEET and JEE, these two angles are very, very, very common, and they will not give you the values for these two angles because they are also considered as standard angle. Okay, now how this combination occurs? This combination occurs when one side is 3 centimeter, 3 meters, whatever it is, other side is 4, and if you add them you will get, by Pythagoras theorem, the hypotenuse will be 5. So 3, 4, 5 is the case where these two angles occur. Okay, now which angle is 37 degree, which angle is 53 3 degree. That is also very, very important. So the angle opposite to the smallest side, angle opposite to the smallest side is the smaller angle, that is 37 degrees. So 37 degrees is the angle opposite to 3, and as you have guessed correctly, angle opposite to 4 is 53 degrees. Okay, so this is 53 degrees. Now in question, in problems, in practice, you have to find, say, sine 53 degree. So what is sine 53 degree? So sine 53 degree means this is the angle that you are trying to find. Sine means perpendicular by hypotenuse, so it will be 4 by 5. Okay, what is cos 53 degree? Cos 53 degree will be not 55, cos 53 degree will be 3 by 5. Okay, and tan 53 degree will be 4 by 3. Right, these are the all angles related to 53 degrees. Similarly, you can write sine 37 degree is equals to 3 by 5, cos 37 degree equals to 4 by 5, and tan 37 degree equals to 3 by 4. Okay, so these are the angles you have to remember. Sometimes while solving you will find that, suppose you find tan theta, you are solving some problem, you found that tan theta equals to 3 by 4, and you have to answer which of the following angle is theta. So what is the value of theta here? Theta is basically 37 degrees. Okay, so these are also possible, this kind of questions are also possible, right? So you have to remember not only the angles, standard angles, you have to remember these two angles as well. They are also considered standard in physics. Okay, you will not face these angles in mathematics or any other subject, but in physics these two angles are very, very common, especially in JEE and NEET exams. Okay, now I hope your doubts have cleared. If you have any other doubts related to these angles or any up to this point, you can mention that in the comment below. I will try to personally answer those comments. Now let's move on to the another part, that is degrees to radians, right? I already said that 90 degrees pi by 2, right? 45 degrees pi by 4. Now how I said that? So for that you have to understand how can we convert angles from degree to radian. Okay, so now degree to radian concept comes from the concept of a circle. Okay, so we generally say that this angle is 90 degree, this is 180 degree, this is 270, total angle obviously 270 and 360, right? This is how we define angles in our normal degree scale. Okay, there are another scale which is used in SI system, which is radian scale. Okay, now radian scale is sometimes denoted by an angle power C, something like that. Okay, so this is generally means that this is in radian scale. Okay, or more subtly we write this as normally theta rad. Rad means radian. Okay, radian per second, you have used that, right? Radians per second in rotational motion. Now radian means they assume that the total angle subtended in the center of a circle is fixed, that is 2 pi radian. Okay, so they say this angle is 2 pi radians. Okay, pi value is nothing but same as your geometry, that is 3.14. Okay, 2 pi radian is the total angle. Now in degree scale we know that this is nothing but 360 degrees. So 360 degrees is basically 2 pi radians. Okay, so what is 1 degree is equals to 1 degree is equals to 2 pi by 360, and what is any other angle theta degree equals to theta degree is 2 pi by 360 into theta. Okay, so they cancel, so you get theta degree is equals to theta into pi by 180 radian. Okay, so this is how you have to convert from degree to radian. It has a lot of applications. For example, if you put theta equals to 90 degree, you get the angle to be pi by 2. Okay, so based on the case, you may need to convert it into radians. Based on the case, you may need to convert it into degrees as well. Okay, so that's how we have to remember how to convert from degree to radian. Degree to radian is very, very essential to remember. I know this is easy, but still I have to teach you, that's why I did it. Now next part is actually based on this concept of radian. Okay, so arc length, radius and angle, there is a relationship between these things that we have to remember. First of all, let us understand what is arc length. So you have a big circle, very big circle. Part of the big circle is known to you. Part of the big circle is known to you. We call that part as arc length. This is called arc length. Okay, this is called arc length. We denote arc length by a symbol S, capital S. Okay, this is the radius. This is the radius, this is the center of the circle. Okay, you know the radius, you know the arc length, and there are some angles subtended by this arc length at the center. Subtended means what? You take a point on the both extreme side of the circle and you join them. Okay, this is called the angle. Subtended at some points. You can take the point over here also, that the angle will be different, right? But this angle is not important. Each and every point will have different angles. So how many different angles we will calculate? So that is impossible for us. But the center for a circle is a fixed point, right? So that's why we say that the angle subtended at the center. Angle subtended. Subtended means you extend straight lines from the, or you join the extreme point of the arc with the center. You join both sides of the arc, and whatever angle these two radiuses made, that angle is called angle subtended at the center. Let's denote this angle by theta. Now here this theta angle is measured in radian. Very, very important part. This angle theta is measured in radians. Okay, so in that case what happens is that there is a relationship between r, s and theta. Okay, so s is equals to r into theta. S equals to r into theta. This is valid for all circles, all arc length. This is valid for all circles, all arc length. Okay, remember this. This is valid for all circles, all arc length, and theta is in radians. Okay, so this is the general formula. This is the general formula. Now there is a special formula for small angle. Okay, small angle means suppose we have very large radius, okay, or large distance from some point, and here we have a straight line, not an arc length but a straight line. Okay, so in that case, if you take this point as your observation, point of observation, say O. Okay, based on different cases, the observation point will be given to you. Okay, generally we say point electric field at some point, so we denote it by point P, right? So this can be your point O or point P, whatever it is. If the distance is very large, if this distance is very large and this length is very small, okay, say DL, then this angle is also very, very small. This angle theta is also very, very small. So in that case, particular this case where the angle theta is very small, you can write DL equals to r theta. Same formula. Generally we denote it by d theta, but for convenience I am not writing this as d theta, but I am just writing it as theta for now. Okay, this is only valid when this angle theta is very small. Theta is very small. Small means what? Generally it is less than 10 degrees. Theta is, if you convert it into degree and check it, it will be less than 10 degrees. That means 10 into pi by 180, right? You can convert it into radians as well. So it is pi. If you take pi value approximately 3 by 18, so it will be 1 by 6. So the value is approximately 1 by 6 if the in radian, because this angle is in radians. Okay, so you have to remember that if this value is less than 1 by 6 radians, generally we consider that angle to be small, okay, in radians. Also in this particular case there are one more extra approximation, that is sin theta nearly equals to theta. Sin theta nearly equals to theta. Again here theta value must be in radians. Theta value must be in radians. Cos theta nearly equals to 1 and tan theta also nearly equals to theta. Okay, so this is a small angle approximation. If the angle is very small, you can approximate that sin theta nearly equals to theta, tan theta nearly equals to theta, cos theta is 1. Here theta must be in radian. Okay, theta must be in radian. Now there is a small task for you. Try to find sin 1 degree equals to what? Sin 1 degree equals to what? Okay, this kind of question is common. Try to find this sin 1 degree equals to what, and do not use calculator. Do not use calculator. Obviously it is not equals to 1. Okay, I have seen students seeing that okay, theta is very small, so it will be equals to 1. Sin 90 is 1, not sin 1. Right, so this is definitely not equals to 1. If you are thinking so, I am giving you a hint. Sorry, I erased it. So you have to understand that sin theta is equals to theta only for small angles, right? Now let's move on to the next part, which is some important formulas that you have to remember. Okay, check that out. Sin alpha plus beta. So this is a common formula. I think you have learned it in your P1, but still I have to do it quickly. Sin alpha plus beta is sin alpha cos beta plus cos alpha sin beta. Okay, first sin cos, then cos sin. Sin alpha minus beta, sin alpha plus into cos beta minus cos alpha sin beta. Okay, what else? We have cos alpha plus beta. So this is slightly tricky. Cos alpha plus beta is cos alpha cos beta minus sin alpha sin beta. So you have to remember that whenever there is a plus sign over here, the sign between is negative. And cos alpha minus cos beta, same thing, but the sign is positive over here. Okay, so in case of cos, whenever there is a plus, here is minus. Whenever there is a minus, here we have a plus. In case of tan alpha plus beta is tan alpha plus tan beta divided by 1 minus tan alpha tan beta, and in case of tan alpha minus beta, tan alpha minus tan beta divided by 1 plus tan alpha tan beta. So these are the addition of the two angles. Sometimes it might come handy. Obviously these are these applications you have done in your first PU So the first equation you have used in projectile motions in your first view. These are also very common. Sometimes you might need to apply that. So sine 2 theta equals to 2 sine theta cos theta. Very easy. Cos 2 theta equals to cos square theta minus sine square theta. Now these are also sometimes comes handy. 2 cos alpha cos beta equals to cos alpha minus beta plus cos alpha plus beta, and 2 sin alpha sin beta equals to cos alpha minus beta minus cos alpha plus beta. 2 sin alpha cos beta equals to sin alpha plus beta plus sin alpha minus beta. Now not super important, but it might come handy, you never know, but these two are very, very important. Let's move on to the quadrants. Okay, so this is also something you already know. We divide, this is origin, this is our positive x-axis, this is our positive y-axis, this is our negative x-axis, and this is our negative y-axis, right? And based on the position of a point on the coordinate system, if we join it with the with the origin, then we get some angle here, right? Now based on where this point is located, the angle, the value of the angle can be positive, negative, or it can be positive or it can be negative. Okay, so first we have to understand what are the quadrants. So this one is called first quadrant. Quad means 1 by 4. Okay, so this is the first quadrant. Okay, this is the second quadrant, not this one. Very, very careful. This is the third and this is the fourth. Okay, so first, second, third, fourth. So it is anti-clockwise direction, here to here, from here to here, then here, and finally here. This is how we define the angles, right? It is always taken anti-clockwise direction. Now you have to remember that some angles in particular quadrant are positive. Okay, some of the ratio of the angles, not angles, ratio. Angle is always positive. Some of the angles, if you are given a negative angle, that means the direction is taken in the opposite direction. That's it. Okay, so if you say minus theta means plus theta. It is minus theta. Okay, and the positive angle is this one. Okay, if you are taking the angles from the positive x-axis, it is always positive. Okay, negative angle means in the opposite direction. Okay, now ratio of the angles are positive and negative based on where the point is. So if the point is in this direction, all the angles are positive here. Sine, cos, tan, cosec, sec, cot, they are all positive. Now second quadrant, only sine is positive, sine and cosec. Okay, obviously sine cosec is the twin brother, but in the opposite direction, that's why sine and cosec are positive. Third quadrant, only tan is positive. Okay, so if I give you an angle which lies here, so for example 120 degree, sine 120 degree will be positive value, cos 120 degree and tan 120 degree will be negative value. You have to understand that. Okay, so sine and cos, by the way, if you forget that, sine and cos, sine theta and cos theta, they always have to be between this limit. It cannot be less than -1 and greater than +1. Okay, the magnitude of sine and cos, sine cos will always lie between this range. Tan can go from 0 to infinity, does not matter, plus infinity to minus infinity, but for sine and cos the limit applies. Sine and cos can always have the maximum possible value of 1 magnitude wise. Okay, so if you are trying to calculate the value, sine will be positive in this quadrant and in this quadrant. Tan will be positive in this quadrant and in this quadrant, and lastly cos will be positive in fourth quadrant and first quadrant. So how we remember it? I used to remember is all sine tan cos. Okay, all sine tan cos, all sine tan cos. Okay, that's how we used to remember it. Now obviously, as I said, remembering is personal choice. If you have any other way to remember it, you can use that, but try to keep it simple. All sine tan cos is the easiest way, and I learned it so many years back and I still remember it, right? So that's how you should remember. If you are remembering something, it should be a lifelong process, not after 1 year if you forget, then that is definitely not the way to remember. Now next is complementary angles. Okay, complementary angles, I told you in the Pythagoras in the ratio of the angle, that if this angle is theta, I said if you know this angle, okay, value of this angle, you can find the other angle. Why so? Because the other angle is nothing but 90 degree minus theta, right? If this angle is 90 degree, obviously, so we know that the angle, three angles of a triangle always gives you 180 degree. So this angle plus this angle are always 90 degree, because the third angle is 90 degree, right? So if you add these two angles, you will always get 90 degree. That's why these two angles are called complementary angles. They complement each other, right? Now complementary angles, this is the formula that you have to remember. Sine pi by 2 minus theta is cos theta. It lies in the first quadrant. Cos pi by 2 minus theta is sin theta. Tan pi by 2 minus theta is equals to cot theta. Okay, so sine becomes cos, cos becomes sine, and tan becomes cot. Okay, so only except tan, it is easy, right? And mostly you will use this two only. This one is used less, but in mathematics all three are important. Similarly, there is another case, sin pi minus theta. Sin pi minus theta falls on the second quadrant. So in second quadrant, sine is positive. Okay, so there is a small mistake, it will be tan theta. Okay, so sine is positive, so sin pi minus theta is sin theta, cos pi minus theta is minus cos theta, tan pi minus theta is minus tan theta. Okay, so these are the two things that you have to remember. Okay, complementary and supplementary. This angle is called supplementary. If you add two angles, theta plus phi, and if you get that as 90 degree, then theta and phi are called complementary angles. Supplementary angles means, suppose you add two angles, alpha plus beta, and if you get the angles to be 180 degree. 180 degree means pi. Okay, so if you add two angles and if you get their some addition value as 180 degree, then they are called supplementary angles, and if you get the angles as 90 degree, they are called complementary angles. Okay, now few identities. Sine 2 pi plus theta. 2 pi plus theta means this angle is 2 pi, and plus theta means it is always in the first quadrant, so it is sin theta. Cos 2 pi plus theta, cos theta. Tan 2 pi plus theta, tan theta. Okay, everything is in first quadrant. So if you are adding 2 pi, then obviously it will be everything will be plus. Now let's move on to the next part of our discussion today, which is basically algebra. Okay, so we are going to discuss the algebra, and let's start with the basic formulas of algebras. Obviously you already know the first two formulas, it is easy. Even third formula is the easiest one. So a plus b whole square equals to a square plus 2ab plus b square. A minus b whole square equals to a square minus 2ab plus b square. A square minus b square equals to a plus b into a minus b. Now these two formulas are also very, very handy. If you have done something in dipole, then you may have faced these two equations. So a plus b whole square plus a minus b whole square can be simplified as 2 into a square plus b square. And a plus b whole square minus a minus b whole square can be simplified in as 4ab. Now these two equations are often used in a lot of derivations in physics. Okay, not only in problems but also in the derivations, where you will get some equations which basically involve these kind of equations, and you have to simplify it in this form quickly. Okay, obviously AB will be not there, maybe R and X, Y and Z. So variables can be something, but A, B this is the formula will remain the same. So students sometimes get confused with physics and mathematics, because mathematics they are always A, B, C, D, E, F, but in physics they are using some different notations based on the particular case, right? For dipole we use A and R, okay? In case of magnetic field you will learn that R and X, okay? So that's why it is very, very important to relate these formulas. Now, let's move on. Quadratic equations. Quadratic equations is one of the common part, right? You have all studied it. If you have not studied it, then you have to remember this. Now ax square plus bx plus c, equations such as these are called quadratic equations. A, B, C can have different values, sometimes 0 as well, right? And it is not always possible for you to solve them. You have done some solution in the past, basically in class 10th, up to class 10th, the values of B and A and C are given such that you can break that and you can make it into two multipliers, right? But right now, from now on, in fact from class 11th, you will face some values which are not always be able to, you will not be able to break them into proper fractions, okay? Factors. So in that case you have to use this equation. This is the Sridharacharya equation, one of the greatest Indian mathematicians, Sridharacharya. He derived this equation, and you can go into internet and read about it. Nowadays his name is almost forgotten, but he is one of the greatest mathematician. He wrote a book, and he has given this formula. Okay, so it is minus b plus minus b square minus 4ac by 2a, right? This is the formula. Now obviously you should know that if b square is greater than 4ac, we say that the equation has real roots, okay? And in physics, what is good about physics, we do not deal too much with complex roots, not at least at this stage. We will deal complex roots in future if you study physics as your honors subject, or if you do MSc in physics, you will have to deal with complex roots as well. But in PU2 syllabus there is no complex roots, so you will always find this is by default is correct, okay? So x is given by minus b plus or minus b square minus 4ac by 2a. Now the values of x can be minus, can be plus. Now based on the situation, suppose you are trying to find displacement, okay? Displacement can be positive, can be negative, but total distance traveled, it will always positive. So based on what quantity you are trying to find out, you have to identify whether to take the negative value or not, okay? So basically if you take the negative value, the entire value will be positive, negative. If you take the positive value, the value can be positive as well as negative based on the cases. But obviously, as I said, b square must be equals to must be greater than 4ac. And these are some roots formula. I have seen only once this is a if you use this notation, this formula, it will be a shortcut method, but generally reserved for JEE and NEET, not required for KCET. But again, if you are preparing for JEE and NEET, you need to know that if you multiply the two roots, okay, you will get c by a. If you add the two roots, you will get minus b by a. x1 and x2 are the roots of this equation. So if you solve this, first using plus you will get x1, using minus you will get x2. That's it, right? And this is a sometimes if you remember these equations, it will be very, very helpful for you. Mathematics anyway you have to remember this, so physics also sometimes might be handy for you, but this is the must remember equation obviously, right? Let's see one equation. 5x square minus 7x plus 2. Apply the Sridharacharya rule and find the roots, okay? I will not do it in this class. So basically x1 and x2 you have to calculate and let me know in the comment below, Okay, let me know in the comment below what is the value of these roots. You have to put the values in this equation and then you have to calculate the roots of these equations. Okay, if it is root, you can use SQRT 5, then I will understand this is square root. Okay, you can use this symbol SQRT because in the comment you are not you may not write square root symbol, so you can use 5 plus square root of 5 and 5 minus square root of 5, like that, whatever. Okay, and if you are writing divided by 2, divided by 3, so you can write in this format in the comment below. I will check and I will let you know if you are doing it correct or not. Simple homework task, not super complicated, but this is a bridge course, that's why I am not doing too hard on you. Next, binomial approximation. So some of you may have done it, some of you may not have done it. So any equation in this form 1 plus x to the power n can be broken into the binomial terms. For example, a plus b whole square, you can break it into a square plus b square plus 2ab, right? This is the common equation. Now if I write it 1 plus say x whole square, what will be the solution? 1 plus 2x plus x square, right? This is the breaking. Now what will happen if I go into 1 plus x whole cube? Then it will be 1 plus 3x plus 3x square plus x cube, right? Similarly you can do it for 4, 5, 6, 7 up to n. So this is the basic, this is the generalized formula. If you have learned about combination and permutation, you know this symbol as well. This is the factorial symbol. Okay, this means multiplication. 2 factorial means 2 into 1. 3 factorial means 3 into 2 into 1. 5 factorial means 5 into 4 into 3 into 2 into 1. Right? So this is the general expression for binomial expansion. We are not interested in this. If you are doing in mathematics, fine. In physics we are not interested in this, because physics generally we do not get this long series too often. What we encounter is that when the value of this x is very small, we encounter this a lot. Okay, you have seen that in case of gravity, you will see that in future as well. If the value of this is very small. For example, if you are asked to find 1 plus 0.01 to the power say 100. So this value is very small. 0.01 is 1 by 100, right? So that is very small value. So in that case, what could be the approximated value of this expansion? What could be the approximated value of this expansion? On that we are very much interested. Okay, so if you do that, you will get the value as 1 plus nx. 1 plus nx. If x value is very small, you can approximate these to be as 1 plus nx. Higher order terms basically, so in this same equation, higher order terms x square, x cube, they are very small values, so we are basically ignoring these terms. You are ignoring all the terms from here up to here. Only the first two terms we are keeping. Okay, this is a approximation. This is called binomial approximation. So if you apply this, you will get 1 plus 0.01 into 100. Okay, that is 1 plus 1, that is 2. So approximated value of this is equals to 2. You can use your calculator and try to find the value and see how much difference it is. This is an approximation. In physics we do a lot of approximation, and a good approximation is always a way to the future. Physicists are basically lazy. Okay, they don't want to do a lot of calculations, they don't want to do a lot of boring mathematics. Okay, you might now, for you might be thinking that what sir, we always do boring mathematics only, but in physics, if you study physics in higher level, okay, mathematics becomes much elaborate and very tedious and boring. Okay, to reduce that, physicists always try to find shortcuts and ways to reduce the workload. This is one of such example where we have ignored all the higher order terms and we are only considering the values which is very necessary, right? Now next is componendo and dividendo, very easy equations. I hope you remember it. If a by b equals to x by y, then you can use componendo dividendo rule and you can write a plus b by a minus b equals to x plus y by x minus y. This is also at times can be handy. And one more thing, if you add 1 in both sides, if you add 1 both sides, you can write a plus b by b equals to x plus y by y. Right, that is also possible. Now that again based on problem to problem, case to case, not super common, but obviously in some cases if you apply these rules, the question, the solution can be done in a faster way. So these are basically foundation for shortcut tricks. So during my lectures, many students come and say, sir, teach us some shortcut, teach us some shortcut. So shortcuts, for shortcuts you have to remember these formulas, which is very important. And next is AP and GP, arithmetic progression and geometric progression. I hope you have learned about that. So arithmetic progression means series, right? A plus D, A plus 2D, A plus 3D, A plus 4D, up to A plus n minus 1 into D. So this is 1, 5, okay, 9, 13, like that. So if this is a series up to n number of terms, okay, what will be the sum of all the terms? Okay, what will be the sum of all the terms? Sum of all the terms is basically given by Sn equals to n by 2, 2a plus n minus 1 into d. Okay, so this is the common sum of all the terms in case of AP. This is another alternating form. In physics, AP, at least at this level, is not super common, but GP is. Okay, GP is very very common in physics, particularly this case. Is very common. GP is instead of addition, it is a multiplier. Okay, AR square, AR cube, AR5, like that. So this is the common general solution for sum of all the terms. And if the value of R is less than 1, that means instead of multiplying, if you are dividing it. Okay, so for example 1, 0.1, 0.01, 0.001, like that. Okay, if you are adding all such terms, what is the sum of all the additions? So in that case, if you see the R value is 0.1, which is less than 1, you can apply this rule and you can find whatever is the value of Sn. Okay, so this is very common in physics. This formula is common. Okay, not so much with AP, but as I am teaching GP, the twin brother of GP will always say that why you are not discussing me. So I discussed AP as well, right? So this is the end of today's lecture. Part 1 ends here. I will be discussing part 2, where I will be discussing calculus and geometry, graphs, etc. So if you if you found anything that you have missed in your PU1, then definitely you would like to subscribe to our channel. Also, if you want to download the class lecture, there is a special announcement for all of you. You have to join our WhatsApp channel. The link of the WhatsApp channel is given in the description of this video. Okay, so don't forget to join our WhatsApp channel, and obviously if you are watching this video, please subscribe to our channel. Subscribers are important to us, so don't forget to subscribe if you think that we are going to help you in your exam preparation in future.